Now question number 76. If at 27 degrees Celsius and 740 mm Hg pressure, 360 ml of nitrogen was collected, then the volume occupied by dry nitrogen at 370 mm Hg pressure and at same temperature will be. Aqueous tension of water at 27 degrees Celsius is also given, that is 620 mm of Hg. So in the first case, we have 360 ml of moist nitrogen, but we should always know that the pressure of dry gas is equal to the pressure of moist gas, that's more, minus aqueous tension. And aqueous tension is already given in the question. Pressure of the moist gas as per the question is 740 mm of Hg, while the aqueous tension is 620 mm of Hg. It means the pressure of the dry gas is 120 mm of Hg. Now, we know that as per Boyle's law, the pressure of fixed amount of a gas at constant temperature and pressure is inversely proportional to its volume. It means the product of pressure and volume is constant, and if we talk about nitrogen gas, the product of pressure and volume in first condition should be equal to the pressure and volume in the second condition. What's the second condition? The second condition is dry nitrogen you are taking at 370 mm of Hg and you need to find out its volume. Let's assume that P1 is the pressure of dry gas that we have right now calculated, 120. Its volume, that's already given here. We have already written here in the question also, 360 ml. So multiply 360, that should be equal to the pressure of the gas, dry nitrogen gas, 370, and the volume we need to find out. So what would be the volume in this case? V2 should be equal to 120 into 360 divided by 370. And if you solve this, you will get 116.76 ml. This would be the volume. And if this is the volume, the correct answer is option 4. I hope this question is clear to you. Let's take next question. Question number 77. If for a reaction A is getting changed into 2B, delta U value is given 1.2 kilocalorie and delta S value is 40 calorie per Kelvin at 400 Kelvin, then delta G for the reaction will be. It means in this question, delta G value you need to find out, and we know that delta G is equals to delta H minus T delta S. So what we need here, we need delta S value as well as temperature and delta H value. Let's first find out delta H value. This is equal to delta U plus delta PV, or it can also be written as delta U plus delta NGRT. It means gaseous mole, change in gaseous moles you have to take here. Now, delta U value is given in the question, that is 1.2 kilocalorie mole. It means we have to just change it into calories plus delta Ng value for this equation. A in the solid state is getting changed into 2B in the gaseous state. It means this delta Ng value is 2 into R value is 2 calorie per mole per Kelvin, that's given in question, and the temperature is 400. So it would becomes 1600, and this is 1.2 into 10 to the power 3. On solving this, you will find out it is 12 plus 16 into 10 raised to the power 2, that is equal to 2.8 into 10 raised to the power 3, and this value is in calories. Now, delta H you have, T you have, delta S value. In this case, delta S value is already given in the question, so delta G value is equal to 2.8 into 10 raised to the power 3 minus the T value is 400 and delta S value is also 40. So this would becomes 2.8 into 10 raised to the power 3 minus 16 into 10 raised to the power 3. This value is equal to minus 13.2 into 10 raised to the power 3 calorie, or in terms of kilocalorie it would becomes minus 13.2 kilocalorie. Where this answer is given, this is given in option 4, and let's choose it as the correct option. I hope this question is also clear to you. Let's take the next question. Now question number 78. If the enthalpy of formation of H2O, that's in liquid state, is minus x kilojoule per mole, and enthalpy of neutralization of HCl and NaOH is minus y kilojoule per mole, then enthalpy of formation of OH minus ion in kilojoule per mole is. Basically in this particular question we have one acid and a base, and the neutralization process would be there, and during that neutralization HCl is giving 1 H plus ion, NaOH is giving 1 OH minus ion to give you H2O. This is the process, and for this particular process enthalpy is, change in enthalpy is minus y kilojoule per mole. So this is the enthalpy of neutralization process. Further, if enthalpy of formation of H2O is minus x kilojoule per mole, then you have to find out the enthalpy of formation of OH minus ion. We should always know that the enthalpy of a particular reaction is equal to the enthalpy of formation of product minus the formation enthalpy of reactant. Now, in this particular case, for this reaction, the reaction enthalpy is minus y because the neutralization process, this is the whole reaction. Enthalpy of the formation of product. There is the product which is water, and its formation enthalpy is minus x kilojoule per mole, that's given in the question, minus enthalpy of the formation of reactant. If we talk about the reactant, there is the delta H value for the formation of OH minus ion we have to take, and that formation enthalpy we need to find out. It means this delta H for the formation of OH minus is equal to minus x plus y, or that's equal to y minus x kilojoule per mole. And if it is the answer, let's identify where it is given. It is given in option 3, and that's why our answer is also option 3. I hope this question is clear to you. Let's take next question. Question number 79. The reaction for which standard enthalpy of combustion of reactant is 8 times of the standard enthalpy of formation of its product is. We have several reactions given here. Basically 4 reactions are given here, and all of these are the combustion processes in which certain substance is burnt to give you certain product, and we have to just identify that reaction for which the standard enthalpy of combustion of reactant is 8 times of the standard enthalpy of formation of its product. If we talk about the standard enthalpy of formation of a certain substance, that is enthalpy change during the formation of its 1 mole when the reactant species were there in their standard states. So we have to first check these combustion processes. If we talk about the first option, carbon is combining with oxygen to form CO2, and 8 CO2 are formed here from 8 carbon atom. Carbon is there in diamond state. This is not the standard state of carbon. Along with that, this reaction is also not balanced. That is why this combustion reaction does not have the standard enthalpy of reactant. That is why for this reaction, standard enthalpy of combustion of reactant is not the 8 times of the standard enthalpy of formation of product. We can ignore this reaction. Further, we have the next reaction where phosphorus is there, but this is the red phosphorus, not the white phosphorus. For red phosphorus, standard enthalpy of formation is not 0, and that is why we can ignore this reaction. Further, we have P4 plus 5O2 is giving you P4O10. In this particular case, white phosphorus we take, and this is the combustion process also, but in this case standard enthalpy of formation of P4O10 is equal to the standard enthalpy of combustion of the reactant, that is white phosphorus. So that is why we can ignore this case also, because it is not the 8 times. Now we are left with the last option. Here we have S8. This is rhombic sulfur. Combining with 8 molecules of oxygen to give you 8 SO2 in the gaseous state. And in this particular case, the standard enthalpy of formation of SO2 is 8 times that of standard enthalpy of combustion of S8. And that's why this is our answer also. I'm just choosing it as the correct one. Further, let's take next question. Which among the following is not an extensive property? All those properties which does not depend on the quantity of the substance are termed as extensive properties. And among all these properties, only density is that property which can be considered as extensive properties. Rest are intensive properties. That's why the correct answer is option 1. Let's take next question.